Hi, I'm Gina Chernetsky and I'm presenting Heirloom. It's a new work that's just about to be exhibited in Copenhagen in a couple of weeks' time. And it's been a process of about 3 years construction with scientist John Hunt. We're working with skin tissue. And basically what it is are two glass, like analogue, traditionally done glass casts of my daughter's faces. They were then 11 and 13, Saskia and Loba. And we took glass cases of them and buccal swabs from the mouth and eyelash and eyebrow follicles, and from that we grew stem cells. And the idea being that we grow skin portraits of the girls. When the skin cells are developed to kind of tissue-based thickness, we then use a process by which we lift those skin growths and place them onto kind of replica vac-formed casts to dry out and fix. So eventually we get extracellular matrix structures of their faces which are kind of preserved, and we hang as portraits. Now in the process of doing this, it's doing a number of new things. It's actually growing stem cells from non-invasive processes. Normally you have to have a skin plug. But also John's invented a system by which you don't need all that scientific equipment, and that's the kind of area we think is patentable. So in some respects, if you can get hold of the fetal cow serum and the antibiotics and know what you're doing, you can do it on your kitchen table with regulated temperature. We found a way of sustaining the CO2 and the nitrogen. So the exhibition is white plinths on which two of these little bioreactors or fish tanks live, and they're fed by fetal cow serum, antibiotics, which drip onto the mouths of the portraits, and there's a kind of overflow and a spinner on the heaters, so the fluid's kept at the right temperature and active, and it goes around a system which is pumped by like an old triple heart bypass pump going through the system, and it makes this beautiful sound of the pumping and the fluid going through the chamber. Now this chamber feeds to another chamber which has the pump in and the mechanics for maintaining the life of the cells, and they're linked with a perspex tube that contains not only the fluid going through the tubes, but it also contains the electrical cables for the web cameras. So we've got two micro USB web cameras that show time-lapse and live growth of the cells, and also a web camera which shows the kind of process of setting up and sustaining the exhibition and also the audience in that place. Now we're also working with FaceLab at Liverpool John Moores University and Caroline Wilkinson, who sees the potential in being able to get scientifically accurate 3D scans of people's faces and the information of that, and mixing it with their DNA or genetic identity. This can help in a medical term, the process for maxillofacial reconstruction in the future. You could actually rebuild a face with its own architecture, with its own cells to reconstruct, and you could not only do that for how you are now, but maybe when you were 20 and you had a face scan when you're 20. We're dealing with ubiquitous technology. For like $200 you can buy a face scanner. It's not scientifically accurate, but it's accurate enough. We're working with FaceLab on the potential future of that genetics and facial reconstruction and 3D scanning. So I'm going to, the video alongside shows you the different processes. What's interesting in it as an artist for me is that we're on the verge of having a patentable process, and for me as an artist, that's very interesting, about the cusp between innovation and research and value, and the value of ideas. I'm really excited about the exhibition, and I hope you're excited about this work too. Thank you.